So number 5. Sorry, I picked the wrong homework set. There we go. Okay, so Maggie, what trouble were you having with this one?
So with that one, I'm just kind of confused on how to kind of eliminate one of the variables and just kind of solving it to get the solution set. I was just kind of confused on how to get that.
So remember, in this case, you are choosing the variable that has either 1 or -1 as its coefficient. So if you look at your list for all the x, y, and z variables, you will see the second equation, the x has just, no number in front of it. So that means your coefficient is 1. So that would be a good choice to eliminate. I would not pick anything from y because you will see y either has +3, -3, or -2 in front of it. So you don't want to pick y since none of them have a 1 or -1 as the coefficient. And then your second option would be z because the first equation has a z with just, +1 as its coefficient. So you can start by eliminating z or x, whichever one you want to eliminate with. So that would be your starting position for that one. And we're actually going to be looking at an example where, again, we will be solving this system of 3 equations. So basically, we can take a look at that example. And then I know, Katie, you said number 9 is the other one with the empty set you were having trouble with. So we can take a look at that one. But let's get into our example right now. Okay. So this is kind of the last example where we had stopped last time, where you had infinite number of solutions for this example. So the next example we want to get into, and I believe, Katie, this will be the example similar to the one you were talking about. So they're asking us to solve the system of equations, and you will see our 3 answer options here are you have exactly 1 solution, infinite number of solutions, or it's an empty set. So like I was showing you guys last time, if for any reason our answers is going to be infinite number of solutions, make sure you look at which variable they are keeping in your answer set. So you will see how this time they are keeping z, which means our x and y values also need to be in terms of z. So that means z is actually going to be the variable you do not want to eliminate. So we'll start by eliminating either x or y, but we're not going to eliminate z. So let's take a look at this example here. So how about we move it to our notebook? Okay, so we are given 3x plus 5y plus 3z equals -1, 9x plus 15y plus 9z equals 10, 2x minus 3y plus 5z equals 4. Alrighty, so this will be our equation 1, 2, and 3. Okay, so since we want to keep z just for the odd chance that we will have infinite number of solutions in this case, we can start by eliminating x or y. Now you will see in this particular example, none of our x or y variables have 1 as the coefficient or -1 as the coefficient. So that really does not work in our favor. But if you look at the y variables, you've got 515 and -3. So, of course, you can see the y value has a negative number in front of it. So that, of course, helps us out kind of with those opposite signs. Now it would just be a matter of, getting the same numbers with opposite signs so that you could go ahead and cancel that out. So I am leaning towards, eliminating y in this case. Now, obviously, we can eliminate x also. The only difference will be when you start eliminating it, you want to make sure one of the numbers is negative, one is positive. So, we'll have to bring the negative sign to our calculation when we start the elimination process. But since my y already has a negative sign on it, we'll just start by eliminating the y variable. So in this case, we can actually go ahead and add our first and second equation, but we're going to have to modify our first equation because you have 15y as your variable in the second equation, and you have positive 5y in the first one. So what can we multiply our first equation with so that we can turn that into a negative 15y? So that our y's will cancel out. Go ahead.
-3.
Yeah, very nice. Because 5 times -3 will give us -15. So we'll multiply our first equation by -3. So that means we are going to add -3 times equation 1. And we're going to add that with equation 2. So let's see, that will end up giving us -3 times 3x will be -9x. Of course, -3 times 5y will give us -15y. And then positive 3z times -3 will become -9z. And then on the other side, -1 times -3 will end up becoming +3. Then we are copying our second equation as it is. So that's 9x plus 15y plus 9z equals 10. So what happens here, guys, when we try to add both these equations? What do you notice?
They all cancel out.
Yeah, all your variables cancel out, don't they? Positive 9x, negative 9x cancel each other out. Negative 15y, positive 15y cancel out. Negative 9z, come on, buddy. Negative 9z and positive 9z cancel out. But what happens on the right-hand side? Do they cancel out? No. So remember, this is kind of what we were talking about last time. So you have 0 on the left-hand side because everything canceled out. But on the right-hand side, I can go ahead and add 10 and 3, which of course gives us 13. And we know 0 does not equal 13. So remember, the only time you get a false statement like this is when you have no solution. Remember, because, and let me show you that illustration again we have looked at last time. Because it's kind of one of these situations where you have the 3 equations, for the 3 different planes, but all 3 of them are not intersecting at a single point or not intersecting at a line of intersection. So it can be something like this, but obviously there can be multiple different scenarios where you have 3 planes that just don't intersect each other. So this is where you end up getting no solution. And of course, that leads you to an empty set. Now, if this was going to be infinite number of solutions, so this was one of those situations where the 3 planes would be intersecting at a line of intersection. In this case, you would have ended up with 0 equals 0 on both sides. So you would have had a true statement, and that's how we would have known that we have infinite number of solutions. Now, if this was going to be one of those situations where you have, that single point of intersection for the 3 planes, then our 15y and -15y would have canceled out. but the x and the z variables would not have canceled out. And remember how we had talked about taking a system which has 3 equations with 3 variables and reducing it down to a system with just 2 equations with 2 variables? So that's what would have happened if you had that one single point of intersection. So this is actually how we know that, we have an empty set, because you got that false statement when you tried to simplify it. And honestly, guys, this is the same thing that would have happened. Let's say if instead of equations 1 and 2, we had tried to eliminate equations 2 and 3 or 1 and 3, any of those combinations, because since it's an empty set, it would not have worked out in any of those scenarios. So questions about this one, guys? All righty. Okay, Angelica, I just saw your message. Yeah, please try to get it, fixed as soon as you can. Okay, let's take a look over here. Okay, so this is actually an interesting application, almost in a way, of where the system of 3 variables, 3 equations with 3 variables come into play. So this is the one where they are asking us to take these 3 ordered pairs that we have, and they are saying use the system of equations to find basically the equation of the parabola in this form, y equals ax squared plus bx plus c, using these 3 points. So basically they're giving you the 3 points, where your parabola has those points. And then using those 3 points, they're asking us to work backwards to find the equation. So let's take a look at how an example like this might work out. So basically our goal here is to come up with the values for A, B, and C. Because, of course, y equals, the y and the x variables, of course, stay unknown when you're just looking at the equation form. So our goal is to basically be able to find those coefficients A, B, and C. And that's where these 3 points are going to come into play. So I'm actually going to go ahead and write down our 3 ordered pairs. So we have, there we go, 3 and negative 16, negative 3, negative 34. Let's see, 4 and negative 34. And we are trying to find the parabola with this equation, y equals ax squared plus bx plus c. So the first thing we have to do, obviously if we are trying to use the system of equations, would be to come up with the 3 equations, right? And that's where these 3 ordered pairs are going to come into play. So we'll start with the first one. Now remember, guys, these are ordered pairs, not ordered triples, because a parabola is a 2-dimensional graph. So remember, each one of these ordered pairs represent your x and y variables. So we're actually going to use these x and y variables and plug them into our equation to come up with the 3 different equations for our system of equations. So we'll start with the first ordered pair. So we have 3 and negative 16. So using this equation for our parabola, y is negative 16. A times x squared, x of course is 3, so this becomes 3 squared, plus b times x, which is again 3, plus c. So when you clean this up, you will end up getting negative 16 equals 3 squared, of course, is 9. So this becomes 9a plus 3 times b plus c. So this is our equation 1. And, obviously we'll follow the same format for the other 2 ordered pairs. So we have negative 3, negative 34. So again, our y value is negative 34. A times x squared, so this will become negative 3 squared, plus b times x, so b times negative 3, plus c. When you clean this up, -3 squared, of course, negative and negative becomes positive. So this guy becomes positive 9a. Positive b being multiplied with -3 will make this -3b plus c. So this will be our equation 2. And then our third ordered pair was 4 and -34. So, following the same example, -34 equals a times x squared plus b times x plus c will end up giving us -34. Of course, 4 squared will give us 16. So 16a, everything's positive here. So positive 4b plus c becomes our equation 3. So you will see how we are able to come up with our system of equations using these 3 ordered pairs. And, obviously just using that general form or the standard form for our quadratic equation or our parabola. So let's put this system together. So let's see, we've got 9a, 3b plus c equals -16. That's our equation 1. For equation 2, we have 9a minus 3b plus c equals -34. And then the last one, we had 16a plus 4b plus c equals -34. So take a look at your system as we have it. And which variable do you think will be the easier one to eliminate? Now, remember, guys, this example is going to be like that first one we did where you have that single point of intersection, right? So where you get one value for A, one value for B, and one value for C. So those will be, our ordered triple per se, as we had done in the example last time. So which one would you want to eliminate first in this system?
Would 1 and 2 be good since 3b and -3b cancel?
Okay, so that would be easy, right? But then what happens when you come to equation 3 to try and eliminate B?
Yeah, so then you could use any of them and just multiply by negative to get a -c.
Yeah, that's kind of what I was thinking also, is that, since all 3 of our C's are just +1, right, with the coefficient, if you can just make them negative, you can eliminate them. So as Katie said, you can technically eliminate any one of these. Obviously, whichever one you think would be easier for you. So if you want to do the B's, that's fine. The only difference would be when you get to equation 3, then, you would have to make sure you're getting those opposites with the 4b and the 3b positive or negative. So I think to keep it simpler, I would recommend start with variable c to eliminate. So again, we'll just start with equations 1 and 2 to start the process. So since both of our C's are positive, we want to multiply and make one of these into a -c. So how about we take our equation 2 and multiply it by -1. So we'll basically end up adding equation 1, we're keeping as it is, and we're adding it with -1 times equation 2. So 9a plus 3b plus c equals -16 will stay the same. And then for our second equation, we will have, let's see, -9a, negative times negative will become positive 3b. Yeah, -c equals, let's see, positive 34. Okay, this has never happened before when I've done these examples where 2 variables canceled out at the same time. So this is an interesting problem in that sense. So you can see your positive 9a, negative 9a cancel out. Of course, we were hoping to cancel out the c's also. So they canceled out as well, but we still have the B variable left behind. So go ahead and add those. And what do you end up getting for your B variable when you solve the equation? So this guy will come out to be 6B equals, let's see, what will that be? 24, 18. So what is our B value? Yeah, very nice. So all you have to do is go ahead and divide both sides by 6, and you end up getting B equals 3. Now, keep in mind, guys, this is not necessarily what might happen when you do this example in your homework, because, we just ended up canceling A, which was not our intention. We were just trying to cancel C, but as you saw in this case, we ended up canceling both of them. Okay, so we've got our B variable. Obviously we need to find A and C still. So as we were starting out with just adding equations 1 and 2, we still need to use equation 3. So we can add equation 3 with equation 2. We can add equation 3 with equation 1, whichever one you think might work out well. So since we have -34 and -34 in both equations 2 and 3, I think we'll go ahead and add equations 2 and 3, and we'll keep the same thing. We'll still multiply our equation 2 with -1 so that we can get those opposite signs on our C variable. So let's go ahead and keep this calculation as it is, and actually, so that we can see what we are doing. I'm actually going to try and do this on this side. So now we will go ahead and add -1 times equation 2 with equation 3. So that will again give us -9A, positive 3B, minus C equals positive 34. And then we're keeping equation 3 as it is. So 16A plus 4B plus C equals -34. So when we add these equations together, of course, your C variable will cancel out. Does anything else cancel out here, guys? Yeah, what else can we cancel? Yeah, you can cancel out your positive 34 and -34 on the other side also. So this will leave us behind with, we are doing 16 minus 9. So what will that be? 7A plus, let's see, 3 plus 4 will also be 7. So 7B equals, C is gone, this side is gone, so that equals 0, which is okay. So you have 7A plus 7B equals 0. Since we already found the value of B in this first part of our equation, you can actually substitute for your value, over here for B, and go ahead and find what A will come out to be. So we have 7A plus 7B. So we'll substitute that B with 3 equals 0. So that will end up giving us 21 will 0. So what does your A value come out to be? So let me know once you have the answer for A. Alrighty, let's take a look here. I've got Cassie, Maggie, Eileen, okay, Megan, Tim, Katie. Yeah, very nice, guys. So all you have to do is move Dom Alrighty, very good. Move your 21 to the other side. And then of course divide by 7. So this guy cancels out here. Okay, so now that we have both our A and B values, all we have to do now is go back to one of the original equations and go ahead and find the C variable. Alrighty. So let's see, one of our original equations. Excuse me, I think I'm just going to use equation 1 over here, but obviously you can use any one of those three. So 9a 3b plus c equals negative 16. So let's see, 9a would be negative 3 plus 3 times b. Remember, b is positive 3 plus c equals negative 16. So what do you guys end up getting for c? Alrighty, very good. I've got Megan, Cassie, Dom, Maggie. Alrighty. Okay, so 9 times negative 3, Jess. Okay, very good. 9 times negative 3 ends up giving us negative 27. 3 times 3, of course, is 9. And so negative 27 plus 9 ends up giving us negative 18. And then when we take that 18 to the other side, he becomes positive. So of course, that ends up giving us C equals 2. Okay, so remember, this is not the end of it. You have just found A, B, and C, but we have to put it back into our quadratic equation over here so that we know what the equation for the parabola will end up looking like. So that's going to be the last step over here. So our equation so A was negative 3. So that means you will have negative 3x squared. B was positive 3. So this will become positive 3x. And then C was positive 2. So this guy will become positive 2. So this is what your final answer will be, not the individual values for A, B, and C. So negative 3x squared plus 3x plus 2. Questions on this one, guys? So as I was telling you that, this is an unusual situation where we were able to directly come up with the B value. And when we tried to solve for the second equation, in our reduced system, basically that just ended up leading us to finding the A value over here. But if you remember, when we had solved our system of equations last time, we were able to reduce our system down from 3 equations with 3 variables to 2 equations with 2 variables. And then, we had to go and simplify it from there. So this is just a little bit of a different experience from what we had done in that first example we had seen. Okay, so that is the last part from your section 5.2, and you will see there's a similar example to one we just did in your handout also, so you can always take a look at that. And I had actually included this word problem in there to just kind of show you, just an application of where this kind of an equation might come into play. So again, if you've not seen your video lecture, then, I would definitely recommend you guys to take a look at some of these examples here. So Katie, does that answer your question about the number 9 you were asking me about?
Yeah, thank you.
Yeah, all right, very good. And Maggie, what about you?
Yeah, that helped. Thank you.
Yeah, all right, wonderful. All right, guys, so that brings us to our last section in chapter 5, since this is a smaller chapter. This one over here, as you can see, we are getting into nonlinear system of equations. Of course, nonlinear means, when you try to graph these equations, you're not going to get a straight line when you graph these. So you can see some of the examples for nonlinear equations can be a parabola, square root function. You can, of course, have the absolute value function, and your exponential and logarithmic functions also can be part of the nonlinear system of equations. So you can see we do actually use graphing for some of these equations, but you will see again, if they are simpler graphs and the graphs will be easy to read, then we can use the graphing methods. But again, your points of intersection have to be nice, easy numbers to read if you're going to be graphing them. If they're going to be fractions or decimals, then graph is not going to be an ideal process or ideal method for solving these. So, of course, we want to get into either the substitution or the addition method to try and solve this. So you've got a bunch of different examples again in this section to show you how to break this down. But one thing we gotta kind of keep in mind is, when you're working with these nonlinear systems, since these are not going to be straight lines, your graphs can actually end up intersecting at more than one point, which means your solution set can also contain more than one point of intersection. If you look at this example over here, this is a parabola. So if we do just a general graph for this parabola, I'm going to show you very quickly how those multiple points work out. So this is our parabola. The second one is just a straight line, with a slope of +1. So this is kind of what the graph would end up looking like. And even though this is, kind of grouped together, pretty close, you do actually have 2 points of intersection because they meet at 0, 0, and they meet at +1 and +1. So you actually end up with 2 points of intersection for these examples here. So let's take a look at some examples from your homework over here. So they're asking us to solve the system algebraically, and then they're asking us to graph it to make sure the answers we came up through the algebraic method is also going to be supported by the graphing method. So let's take a look at how, algebraically we can go ahead and solve this equation over here, or this system actually. Okay, so our 2 equations are y = x², which we know is going to be a parabola. And then we have 9x minus y = 20, which is going to be a straight line. So if you have to solve this algebraically, you want to either try and do substitution or the addition method. Now, in this case, addition method really is not going to work out too well. So I would say, instead of doing the addition method, substitution is going to be pretty easy. You've already got the first equation set up as, y = x². So we can just use that to substitute in our equation 2. So let's do the substitution method. We are actually going to take this value and replace it in our second equation. So you're basically substituting equation 1 into equation 2. So that will end up giving us 9x minus y equals 20, but instead of y, we're going to use that first equation and replace our y with x squared. So this will end up giving us 9x minus x squared equals 20. You know, if we put this in standard form, let's try and get all our terms on the same side. And to keep my x squared positive, that's why I'm moving x squared and 9x to the right-hand side. You can move 20 to the left-hand side and then just multiply everything by -1 if you wanted to do it that way. But it will make it easier if we can keep everything on one side. So you've got positive x squared minus 9x, and then we had positive 20. And then since we canceled out everything on the other side, your other side becomes 0. So you will see this just ends up turning it into a quadratic equation, right? So you can use quadratic formula, or you can try factoring. And if factoring works, you know, that would be an easier process. So let's try factoring first, and if it does not, we'll do the quadratic formula. So we're looking for two numbers that multiply to give us positive 20 and add up to give us negative 9.
-5 and -4.
Yeah, very nice, Morgan. -5 and -4, because negative times negative will become positive. So that gives you positive 20. But then when we add these guys together, it gives us negative 9. So you can factor this into x minus 5 and x minus 4. And you know, of course, set each one of these equal to 0. And you will see how you came up with two different x values. So this tells you that you have 2 points where these graphs are going to intersect. So now that we have our x values, we just need to find their ordered pairs by finding the y value. And you can use any one of the two equations to help you find the y value. And I think I'm just going to use equation 1, because, you know, obviously it's pretty straightforward. So y equals x squared. So let's do for the first point, x equals 5. So what is your y value going to come out to be for x equals 5? So what will this ordered pair be for the first one? Yeah, very good, guys. You're just squaring the x value. So it's going to come out to be 25. So that ordered pair, you know, will of course end up becoming 5 for the x value, 25 for the y value. And then on the other side for x equals 4, what do we get for that? Yeah, very nice. Exactly. We will end up getting 4 squared, which of course will be 16. So that ordered pair is going to be 4 and 16. So these are actually part of your solution set where the two equations will be intersecting. So we will have 5 and 25 and 4 and 16. And you know, remember, I always tell you to check your answers. We know it's going to work for the first one, so it will not be a bad idea to check this for the second equation and make sure it works. So you would be doing 9 times 5 minus 25. Will this give us a true statement? When we try to check for the second equation, 9 times 5 minus 25, will that give us 20? Yeah, because 9 times 5 is, you know, of course, 45. So 45 minus 25. Oh, come on, buddy. Will end up giving us 20. So that ordered pair works out. If you try and check this for 4 and 16, This will be 9 times 4 minus 16. And again, that should give us 20. So let's see. 9 times 4 is what? 36 minus 16 will also end up giving you a true statement. So it checks out for both of them. And you know this is going to work. Alrighty, so now let's do this with the graphing method. So our two ordered pairs were 5 and 25, comma. The second one was 4 and that should be 16. There we go. Okay, now we're ready to graph this. Okay, so we'll start with the parabola first. So use our parabola tool. And looks like they're actually having us do the points to graph this. So since this is y equals x squared, that's your, parabola at the origin. So we can do 0, 0 as our vertex. And then we're actually not going to have 5 and 25. We can do 4 and 16. 1, 2, 3, 4. What can I do as my third point over here, guys? We've got 0, 0, 4, and 16. What do you think our third point can be? If you try and use symmetry, where do you think that would put us?
-4 and 16.
Yeah, very nice, Megan. Exactly. If you just use symmetry, we can go the other side from our axis of symmetry and do -4 and 16. Alrighty, perfect. And then, of course, we need to have our straight line. So again, we know these 2 points, 5 and 25 and 4 and 16 also fall on our straight line. Now, since we don't have the option of doing 5 and 25 because our y-axis only goes to 20, we can still do 4 and 16 for this guy also, which will have, need to be up here, 4 and 16. So we can do that. And what other point can we use to graph that line 9x minus y equals 20? Does anybody have an ordered pair? Does that work, Emma? -4 and -16. Let's try that. So if we did 9 times -4 minus -16 actually ends up giving us -20. So that would not work. Keep it simple, guys. What I would do is literally I would just make my x value 0. Because that would give you your y-intercept and then see what you get for the y value. So this guy becomes 0. So he's basically gone. You're left with -y equals 20. Just divide by -1 and you get y equals -20. So that would be the ordered pair of 0, -20. And since we do have a grid of 20 by 20, you can actually use 0 and -20 as an ordered pair. So what's happening over here is, this is kind of dumb on the designing part of things, because if your solution set is 5 and 25 as one of the ordered pairs, obviously our grid should have been a little bit bigger. than what they are showing us over here. So obviously this doesn't help us when they leave it. So let's check our answer and you will see this works out. So just to show you very quickly, since we were not able to see it on this graph, we've got y equals x squared, and then we have 9x minus y equals 20. Okay. Okay, so the first ordered pair where the two graphs are intersecting are going to be right here at 4 and 16. And we can zoom into that point and you will see the two graphs are exactly on top of each other at that point. The other one we had was 5 and 25. So let's zoom into that point over here. And of course, you will see that right over here, 5 and 25. Again, you can keep kind of zooming in and you will see again, those two graphs are overlapping. And just the way the graph is coming out to be, if you try to zoom in too much, it just looks like there's a whole line that's overlapping on top of your parabola, but it's actually only those 2 points which are going to be, the same between the line and the parabola. Everything else is going to have a little bit of gap between them, but that's kind of what the graph would end up looking like. But as far as solving the system goes, did you guys have any questions on that? Okay, so since we had not seen the substitution method in a while, obviously it was kind of nice to see just for a change, what the substitution method works like. All right, so our second example over here is asking us to again graph the two equations on the same grid, but first we need to solve this algebraically. So let's take a look at how we can break this guy down. Okay, so let's see, we are given y equals absolute value of negative 2x and y equals x plus 3. Now, in this case, since you have absolute value of negative 2x on that first equation, we again cannot use addition method to solve this. So we'll use substitution again. And what will happen with substitution in this case, guys, is you'll essentially end up setting the two equations to equal to each other. Because let's say if I substitute equation 1 into equation 2, I'll be replacing this y value with basically this expression, from our first equation. So again, we are going to be using substitution. So again, we're moving equation 1 into equation 2. So that will end up giving us absolute value of negative 2x is equal to x plus 3. Now, remember when we had talked about absolute values, remember we had talked about how absolute value is the distance of a number from 0. So I can get the same distance going on the positive side and I can get the same distance going on the negative side. So this actually tells us that, remember when you're solving absolute value equations, you have to set it up one's equal to positive, one's equal to negative. So we'll still need to do the same thing over here. And if you need to review how to solve absolute value equations, we had done this in chapter 1. I'm not entirely sure which section, but I'm sure if you go through and look through your notes, you'll be able to find it, but that's going to be part of chapter 1. So the way you're going to set this up is we will have negative 2x equals x plus 3. So pretty much you're just getting rid of that absolute value symbol for the first equation. But then for the second one, because this is equal to our positive one, so then the next one will be negative 2x equal to negative x plus 3. And I'm negating the whole second side, so I'm putting that in parentheses. So one side is positive, so pretty much the same thing as the original equation without the absolute value symbol. And then the second one is where we bring that negative in. So let's start with the left-hand side equation first. Since we want to get x by itself, we'll go ahead and subtract this x, move it over to the left-hand side, and then get your answer for x. So what will the left-hand side give us for the x value? -1, alrighty. So when we add our x values together, that ends up giving us negative 3x equals 3. Very nice. So when we divide both sides by -3, x equals -1. And then for our second side, of course, we'll need to start by distributing that negative sign inside the parentheses. So negative 2x equals negative x minus 3. So now when we move our x value, it will become positive x. And what will this side end up giving us for the x value? Let's see, very nice. Yeah, so this guy will give us, Katie, good. So we have -2 plus 1, which will give us -1. So negative x on this side. We've got -3 left behind. So when we divide both sides by -1, we end up getting x equals +3. Alrighty, perfect. So you have your two x values now. So we need to go back and find the y value. So again, you can use first equation, second equation, it doesn't matter, whichever one you want to use. Let's use the second one, y equals x plus 3. So we'll start with x equals -1, and then we'll come back and do x equals 3. So can you tell me what your y value comes out to be for x equals -1? +2, yeah, very nice. -1 plus 3 will end up giving you y equals +2. So that ordered pair is going to be -1 and +2. And then what about the second x value? What's your y value for this guy? Alrighty, very nice. Yeah, you're just adding 3 plus 3. So y equals 6, and this will be our ordered pair 3 and 6. And again, if you want to check your answers, you can do that very quickly up here. So if you look at this, we have the ordered pair -1 and 2, 3 and 6. So if we did 2 for the y value, and I'm using my first equation here, and then absolute value of -2 times -1, well, -2 times -1 automatically becomes positive, but also absolute value symbol always makes stuff positive. So you can see this works out for the first equation. 3 and 6, y value is 6. This is -2 times 3, which will give us -6. But because of that absolute value symbol, it ends up becoming +6. You can see it checks out for the first one. And obviously, we just use the second one to find these. So we know it works for the second one also. Okay, let's go ahead and plug these guys in. And then they're going to ask us to choose the graph. Let's see, you're choosing out of these three. So I'm going to give you a second here and, tell me which graph should it be, A, B, or C. Okay, Katie, you're going with graph C. Jess also, okay. Jacqueline. Okay, so the first thing, if you look at just the equations for, the two equations you have, this is absolute value of -2x. Now that negative sign is inside the absolute value symbol. So that actually tells us this absolute value function is actually going to be opening upwards. If it was going to open downwards, then your negative sign, should have been outside. That's what would make this open downwards. So that's why we know this is opening upwards. And then if you look at your equation, you can see this is a positive slope. So since this is a positive slope, we know the line is going to be going in this direction. So if you look at this middle one, you will see this is a line going downwards. So since it is going downwards, this is not going to be our graph. In graph A, of course, you can see your absolute value function is opening downwards. So that obviously eliminates option A also. So option C is the only one that satisfies both those functions. But additionally, look where your points of intersection are. This one right here is pretty close to the y-axis. So this definitely can be our point -1 and 2. This one over here, you can see is a little further away and a little higher up. So we know this can be the ordered pair 3 and 6. So even if you were to just look in terms of ordered pairs, you would see this is too far out. So this cannot be -1. And this guy was actually too close to the graph, but we cannot just base it on that because we don't know what the scale of your x and y axis is, but this guy is definitely too far out to be at -1, +2. So, some things like that can definitely help you try and decide which graph would make more sense. Alrighty, so it's going to be graph C. And I think that should be the last part over here. Any questions on this example over here, guys? Already. Okay, so this one actually is a little bit of a different type of an equation, and we will be actually seeing these types of equations in chapter 7. So these will be, I'm trying to think. They don't quite look like circle to me, so they have to be ellipses. And, when we're talking about ellipses, kind of imagine like that oval kind of shape. So you can imagine these are probably two ovals, and I'm not entirely sure. We would have to graph this to see how they would intersect, but let's just imagine they're going to do something like this. So what happens in this case is if you're going to have these two oval or circular objects intersect each other, you will notice they're actually going to form 4 points of intersection when you're trying to solve something like this. So again, you can see we're still seeing that same theme of multiple points of intersection for this guy. So let's go ahead and see how we can solve, something like this. So again, we'll move it over here. Okay, so we have 3x squared minus 5y squared equals negative 33. Actually, now that I'm looking at this closely, it actually looks like it could be an ellipse and a hyperbola, actually, instead of being two ellipses. So we've got 3x squared minus 5y squared negative 33, 2x squared plus 3y squared equals 35. Okay. So as I said, these are actually going to be more like an ellipse with a hyperbola because of that minus sign. So you would still actually end up with 4 points of intersection no matter what in this case. So let's go ahead and break this guy down. So just as you're looking at these two equations, any kind of thoughts on how you would want to solve this? Would we want to do substitution, or would we want to try and do addition? Because again, remember, graphing is never reliable, so we don't really want to do the graphing method. So what do you think?
Addition?
Addition?
I don't know.
Yeah, because if you try to do substitution, I mean, substitution is possible. It can work out, but I actually find addition to be a lot easier with these types of examples. So what we're going to do is we're actually going to leave our x squared and y squared as x squared and y squared for now. We're not going to try and, just get x by itself or y by itself. We'll do that after, we do the addition method. So since your y variable already has the positive and the negative side, we'll start by eliminating the y variable. So what do you think we need to multiply our equations with to be able to eliminate y? And do we just need to multiply one of them or both of them? Both of them, Alice? Okay, so what are we multiplying our first equation with? Because what would be common between 5 and 3? What number would be divisible by both 5 and 3? Yeah, since 15 would be the common factor. Very nice, Alice. Yeah, multiply the first equation by 3, and then what do we multiply our second equation with? Yeah, so if you want to get these guys to be positive and negative 15, multiply the top equation by 3 and then the second one by 5. And let's see what that will end up giving us. So we are adding 3 times equation 1 with, let's see, 5 times equation 2. So 3 times 3 will give us 9x squared minus 5 3s are 15y squared equals, what will that be, negative 99? Okay, second one would be 5 times 2 is 10x squared plus 5 times 3, 15y squared, and then what will be 35 times 5? 175. Alrighty. So as we had hoped, our negative 15y squared, positive 15y squared cancel out, leaving us behind with, let's see, 19x squared. And what is 175 minus 99 going to give us? 76. Okay, so now is when we want to try and get x by itself. So first of all, we'll start by dividing both sides by 19. And this works out good for us because you will see when you divide 76 by 19, we end up getting 4, which is, obviously we know it's a perfect square number. So now that we have to get x by itself, this is where, we would end up taking a square root on both sides. Now, guys, remember, this is very important for us to get those 4 points of intersection. It's actually coming from this plus or minus on your x value. So square and square root cancel out. We end up getting plus or minus 2. So you will see we're actually getting 2 x values from here. Alrighty, so we've got our x values. Now we need to go back and find the y value for each one of those x's. So I guess I'm going to use equation 2 since we have a positive 35 on the other side. We won't have to worry about negative signs. So I'm going to use that second equation to find our y value. And that guy is 2x squared, 3y squared equals 35. So let's start with x equals 2, and then we will do x equals negative 2. Okay, so if we take a look at this guy here, we have x equals 2, so that would become 2 squared. So 2 times 2 squared plus 3y squared equals 35. So basically you're multiplying, 2 into itself 3 times if you really think about this. 2 times 2 is 4, 4 times 2 is 8. And, just go ahead and solve that like you would any equation. We are trying to get our y value by itself. So what will this end up giving us? So 35 minus 8 will be 27. And again, 27 goes into 3. So that would be a nice, simplification. 27 divided by 3, of course, gives us 9. So again, a perfect square number. And this time, same thing you will do here that you did with the x value. Take a square root on both sides, but remember, again, with the square root, we get a positive and a negative sign. So you will see this is actually where our 4 points of intersection are coming from, because for one single x value where x is equal to 2, we came up with 2 values for y. So you have y, 2 and positive 3 as one ordered pair, and 2 as negative 3 as your second ordered pair. So 2 answers coming from, one single x value. So obviously on the other side also, you should get the same kind of thing. So this guy will be now 2 times negative 2 squared plus 3 times y squared equals 35. Since we are doing negative 2 squared, negative times negative will become positive. So this will give us positive 4. Positive 4 times 2 will again give you 8. So you will actually see, in this case, we end up doing the same calculation again. So obviously your y values are going to come out to be the same answers. And honestly, we don't have to do the calculation again since we know it's going to come out to be the same answer. So these ordered pairs will be negative 2, positive 3, -2, -3. Sure, these guys cancel out. And then these are going to be our 4 solution sets. So with these types of equations where you have the x squared and the y squared, you should expect to see 4 ordered pairs for your solution set. Now, of course, there can always be exceptions to the rule, but for the most parts, most of the examples that I have solved, we have come up with 4 solution sets with these guys. And, as you can see, they basically just are the same number, right? 2 and 3 that just end up changing signs on them. So 2 of the ordered pairs have positive 2s, 2 of the ordered pairs have negative 2s, and the same thing with the 3s. 2 ordered pairs, as you can see, the first and the third one have positive 3 for the y value, and the second and the fourth ordered pair have -3, for the y value. So it just kind of, goes in that cycle from positive to negative. Questions on this one over here, guys? And, again, you can just throw this in your calculator, but, just make sure you check all 4 of those ordered pairs just to make sure they will satisfy each of those equations. Any questions with those guys? Alrighty. So let's go ahead and put these in. What happened? There we go. Okay, so +2, +3. Then I'm going to keep the +2, but make it -3. And now let's change it to -2, +3. And then -2, -3. So that takes care of all of those. Yes, Jess, that is correct. All righty, very good. Okay, and then I believe we have one more example to take a look at. Yeah, and this one over here, I wanted to do this since this was involving, our exponential function and logarithmic function. So they're doing a combination of, they're still nonlinear, but, obviously remember the reciprocal functions of each other. So let's see what happens when we try to solve, something like this over here. Okay, so this guy has y equals 9 to the power of x, and x equals log of y with base 81. So since you will see the way these equations are written out, right? You have y equals 9 to the power of x, and the second equation is x equals log of 9. Log of y base 81. So this is the one where I would actually use substitution again instead of addition method. So what we want to do is actually substitute the y over here by using, our first equation. So again, we're going to do substitution. We're substituting equation 1 into equation 2. So this will end up giving us x equals log of y. So instead of y, we're replacing it with 9 to the power of x with base 81. Now, any ideas what we can do going forward from here? Just kind of remembering the stuff we did in the last chapter.
Would it help if you changed the 81 to 9 squared?
Not at this point. Once
Okay.
we clean it up a little bit. So what should we start with before we do that?
Should we change it to exponential form?
Okay, so how would we do that? So let me write down that conversion again for you guys. If you have a to the power of x equals y, then remember when we're writing it as a log, that becomes log, of course, same base of y equals x. So if you try to use this conversion, what would you rewrite this guy as in the exponential form? Okay, so Jess, I'm looking at your answer. You've got 81 to the power of x equals 9 to the power of x. Megan, you have the same thing. Jess, quiz and exam both are on Wednesday. Yeah, because we will be finishing chapter 5 today, and I'll talk about that here in a minute. So yeah, very nice, guys. So remember, you take the base of your logarithm, which becomes the base of your exponential function also. And then remember, your log is always equal to an exponent. So this single x on the left-hand side will become the exponent on 81. And then you have, of course, equal to 9 to the power of x. Very good. So now we can rewrite our 81 as 9 squared, because now you will see how easy it becomes for us to break this down, or at least I'm hoping you can see that. So let's go ahead and write that 81 as 9 squared. So remember, you can multiply your exponents when you have that single base. So 9 to the power of 2x equals 9 to the power of x. Now what can we do here, guys?
They
Remember,
have the same base, so can't we just do 2x equals x?
yeah, using the one-to-one property for exponential functions. Very nice. So since you have the same base on both sides, by that one-to-one property, you can take your exponents and set them equal to each other. Now, if you are tempted to divide by x, don't do that, because we don't want to eliminate the x variable. So you are actually going to subtract and bring the x on the same side. And we end up getting, 2x minus x will just basically give us 1x, and the other side became a 0. So you found your x variable. Of course, you want to go back and find your y variable. So can you tell me what your y variable will come out to be using whichever equation you want to? and use one of the two original equations to find the y value. Megan, y equals 1. Okay, so as you can see, the first equation will be easier for us to work with because with the other one, your y is inside with the log function, right? So if you just actually use that first equation, y equals 9 to the power of x, you're basically doing 9 to the power of 0. And by the 0 exponent rule, we know it's going to end up becoming 1. So your ordered pair so this one actually did give us a single ordered pair of 0 for the x value, 1 for the y value. And of course, you can go back and check your answers in both the equations. Coming back over here. There we go. All righty, very nice, guys. Did anybody have questions on this example over here? So just to again kind of show you, you do have a bunch of different examples in your handout also. So if you need more help, this is kind of similar to the one we did with the ellipses and the hyperbola. This is a little bit of a different type of example, but again, you can see how we solve this, in your lecture to help you break down. There was just another example here with the log functions if you wanted to look at it. And like I said, we had some application problems to help you out also. So this is basically what you guys are working on, just sections 5.2 and 5.3, because, obviously remember 5.1 was just a review section. So you have no homework, no exam questions on this. So as you were asking me about Wednesday, Jess, basically we have the exam for chapter 5 on Wednesday, because since this was such a short chapter, obviously we're not taking too long to work on this. So your deadline for the homework assignments and the quiz is also for Wednesday. So that's the 14th. And then we're also taking our chapter 3 exam on the 14th. Do you think that would be fine with you? Because if you want to move the exam to the following Monday, which would be what? The 19th, we can move it to 19, but then we have to use Wednesday to do chapter 7 because we are, so close towards the end of the semester that, we have to use every single class period as much as we can. So then Wednesday would be about doing chapter 7. So it's up to you guys. If you want to move the exam to the 19th, we can, but then Wednesday we'll be talking about chapter 7. Or if you think you're confident going into the exam on Wednesday, then we can keep the exam on Wednesday. So take a minute, think about it. Okay, so just Wednesday is okay for the exam, you said? How about the rest of you guys? Would Wednesday be okay? All right, I'm seeing a couple thumbs up coming up. So anybody who is not okay, Eileen, you're also okay? All righty, not seeing any of you coming back with Wednesday is not good. So we'll leave Wednesday as our exam day. Yeah, Dom, not a problem. And then, okay, Alice, not a problem. So we'll keep the exam for Wednesday then. And, just those 2 homework sections and the quiz is all you have to do for chapter 5. So we'll finish chapter 5 on Wednesday, basically. And then coming next week, we're basically getting into chapter 7. We'll finish chapter 7. I'm hoping we should have one day to do review before the final, but that's basically what we're looking at towards the end of the semester here, guys. Finishing chapter 5 Wednesday, probably take 2 or 3 days to finish chapter 7. We do have an exam for chapter 7, and then we get into the final exam. Now, your final exam is going to be comprehensive, so it's everything that we have done from the beginning till the end, which will be going from chapters 1 to chapter 7. Of course, we're not doing chapter 6. We skip over that. Your practice final exam is already available in my math lab. So if you guys want to start just looking at it for practice purposes, you can. There is no grade for the practice exam. So, don't feel bad if you don't get a grade that you're happy with. So that's kind of what we are looking at as we move forward towards the end of the semester, you guys. Betsy, we normally try to keep it at 30 questions for the final exam. Because again, we're taking the class time to do the exam, so we try not to make it too long. And sometimes I actually even have less questions if some of the questions have multiple parts to them. Then instead of having 30, I might do, like 27, 26 questions, something like that, depending on how long the test ends up being. So I'll have to take a look at the final to see what I ended up with, but no more than 30 questions. All right, guys, if you don't have any more questions, then we're going to stop right here for today. And then I will see you guys on Wednesday for the chapter 5 exam. So have a great day, guys. Be careful. And I will see you on Wednesday morning. And Dom, you can stay back and I can answer your questions.
Did you say